Hello everybody, and welcome to the Experiments with dgraph-vector-embeddings video. This is a video I've been meaning to make for a couple months. I'm Matthew McNeely. I'm an independent software consultant, and I specialize in graph databases and graph architectures. Several months ago, as some of you probably know, dgraph released v24, which added support for vector embeddings, and that was pretty exciting. So I decided to update my Seinfeld knowledge graph, which is this graph that I have with these vector embeddings, just to see what we could learn from it. It was a great way for me to test out what's going on with dgraph and vector embeddings. So what we'll do in this is we've got a little agenda here. So I've put everything in a self-contained Docker image, and we'll go through how you run that, and then we'll go through quickly the Seinfeld knowledge graph that I created last year, I think. It's going to be the basis of what we do, and we'll extend it with these new features in dgraph, and then we'll look at how embeddings are declared in the dgraph schema itself. We're focusing on GraphQL, not DQL this video, and we're going to create vector embeddings for all episodes and all lines and insert those into dgraph. We'll show that in Python, and then we'll go through some GraphQL queries and queries for similarity search using these embeddings, and then at the very end we'll talk about some caveats, some things that I found that you might want to be aware of. All right, well, let's move on to the actual running of the Docker image. Okay, so we want to run this Docker image, and I find a lot of times just like getting the artifacts all together and stuff, it's like one of the hardest parts of doing experiments and checking things out. And what I do for my clients a lot of times is I'll actually just create a Docker image. It's got everything in it, like got a schema, it's got all the data files, it's got dgraph in it itself, so they can just run it and like test something out or verify something. And that's what I've done here. The image is up on my Docker Hub account, and it's called dgraph-vector-experiment. And by the way, I'll leave all these links in the comment of this video, so you'll have links to everything. So yeah, if you run this guy now, for me, I had all these images, of course, are cached on my machine, so it's going to happen right away. If not, if you don't have them cached, if you haven't done this command yet, it's going to take a while for everything to download. If you're following along and you're running this along with me, then you might want to just pause it until everything's downloaded. When the image does come up, goes in the container, you'll see that in there dgraph is running in this container, as well as a copy of Jupyter Lab. And you can probably see this guy here. You'll find this little link in the output, like saying, yeah, here's a token to get to it. And what I'll do is I'm going to copy this. And then I'll paste it in. I have a clean browser here, and we'll paste that in. So here's the lab that's running, and if you just want to do a sanity check, you can actually see in this container we've got both lab running as well as a dgraph cluster. So great. So I think the next thing to do is look at the actual schema and what's it like to add vector embeddings into a dgraph schema. As I mentioned at the beginning of the video, we were going to use this Seinfeld graph as a basis to do our experiment with dgraph similarity search. And just real quickly, this Seinfeld graph is something that I created a while back, and it's just a knowledge graph that links together all the seasons and episodes and lines and characters all in a graph. This particular version is in dgraph. So it's a good candidate for us to to actually go through and modify this schema to support these new vector embeddings that dgraph now supports. And I just run over to my IDE real quick because it's kind of better to look at it here, I think. So the changes that you have to make for this support for vector embeddings basically comes down to adding these vectors directly in the types, in your GraphQL SDL types. In this case, we have a float and this new keyword or a new directive that was added to dgraph in v24 called embedding, which is an indication to the index that this is something that's going to be searched using what I think right now is probably is the only similarity search function they've added, but it looks like maybe the way they've defined this is that at some point maybe they'll add other types of vector space searches. This is the well-known hierarchical, navigable small worlds algorithm. Facebook has one. There's a dozen others, and there are 3 techniques in that algorithm to search. I won't go into them in detail here, but there's cosine similarity. There is I think a quadratic, or no, a Euclidean, as well as dot product. And the way the documentation describes, you can use these, either one of these similarity search algorithms, with this base search function. And then this exponent is like I guess a hint that goes to the function, and it is basically an indication of how many vectors you expect this index to maintain. I guess it doesn't actually. I looked at the code in the dgraph code. It doesn't appear to affect how the index sort of pre-allocates or anything. But what it does is it passes this hint along to the actual algorithm so that it can do some pre-allocation or something. I haven't got into it really clear. The documentation right now isn't super clear on that either. But in this case, this is an exponent, and it's to the 5th, right? So that's 100,000, and there's 50,000 lines in 56,000 lines in this knowledge graph. So we have to err on the side, I guess, over. Also in episode, there's a summary. Each episode's summarized, and we also add a similar vector here using the exact same directive. The only difference being that we lower the exponent to 3 because we only have a couple hundred of these summaries. Well, there's a couple hundred episodes, so there's only a couple hundred summaries. All right, we'll pause right there for a second, and then we'll move on to something else. Right, so now we're back to the Jupyter Lab, and we'll open up this notebook that's included in that image. If I can double click on it correctly. What's going on? Okay, there it is. So first off, there's some required libraries. We're using the Hugging Face sentence transformers, and then IPyWidgets is kind of, otherwise it's glocks if that's not here, and then just a generic Python GraphQL client, so we can run some GraphQL things. So I'll execute this. This takes a bit of a while, so I'll pause my screen. Okay, that's finished. It took about a minute, so that's not too bad. I'm going to change my theme to dark so my eyes don't burn. So at the very end, you'll see that it successfully installed all these things, and blah, blah, blah. You're all good. And then this is just a little utility code to run just to make sure that we actually can, in fact, get to dgraph from this notebook, the dgraph that's running inside this container. So it's reported that we're cool. And then finally, or not finally, but the next step is to import this and to update this schema. So right at this moment in this container, dgraph, this cluster we have running is just completely empty. It's got no schema, no data whatsoever. So the next step is to actually apply this schema that we just reviewed. And I'll do that here. And the schema was applied. I will point out there's this really handy utility. I'm going to copy this link, or maybe I won't. I'll have to do it like this. There's a handy utility from the people at Apollo, the GraphQL people. A lot of people don't know about this, and I think it's pretty handy. So you can this is like a little sandbox that allows you to, just, without setting up, Apollo GraphQL, the whole stack and everything, or logging in, it allows you to run this little sandbox, and this is pretty handy because you can then, have a look at the entire schema. And this is, this is the schema that we just applied, and just it goes on forever. There's all these different objects and queries and mutations and types and stuff like that. So this little explorer, kind of gives you, you just really quickly, start looking at schemas or running test queries and stuff like that. So one of the great things about dgraph is when you apply a schema, like we went through earlier, you get this auto-generated API for inserting, mutating, and querying every type that you've defined. So in this case, our Seinfeld knowledge graph, we've got lines and episode types and season types and characters, and they're all sort of obviously linked together. And when dgraph sees that and ingests that schema, it automatically generates these functions for you. It's basically a complete GraphQL API in which you can then start issuing queries. And that's really handy. And one thing that happens now when you have a vector embedded, when you have an embedded index using that directive embedding, what will happen is you'll get some auto-generated, I'm going to move this over here, you'll get some of these similarity searches auto-generated for any type that has this embedding directive. And in this case, because we added those embeddings to both line and episode, it auto-generates these query endpoints for us to use. And I'll go through some examples of those in the notebook coming up, but I just want to point that out. That's a pretty powerful feature. So here comes the meat of it. So what I want to do now is just kind of talk a little bit through how these vectors need to be generated and how we'll insert all this information to the graph along with these embeddings. The best way to do that, alongside this image, we've got these a couple of these importers that are there for your use, and you can kind of see them being imported here. I'm going to jump back over to the IDE because it's a little bit easier to kind of look at them with syntax highlighting. So if we look at, let's look at the episode importer, and what it does is it takes this, the function itself takes this model, and the model you'll see back in the notebook is created. And basically what it does is it goes through a CSV file and creates all these entries to actually import into the graph. And here's the part where it does that. So basically we're calling the model encode function here, and then we're just doing a little shorthand stuff where we're iterating every item in the list that we've built up, which is like the title, the air date, the directors, the writers, the season, all that stuff, the summary. We're adding all that, in a big loop at the very end. We just sort of do this little shorthand thing in Python where we apply for each item in this list the summary. We're using that to encode, so that gives us back an array of all of these embeddings, and then another little shortcut thing in Python where we apply that embedding array into the list, and then we derive a new list. So now the list at this point has all of the episodes, and then every single vector for that summary. So they're all assigned in one large object, and the whole thing gets committed all at once in a transaction. I'll head back now to this script, and we'll actually run this. This actually takes quite a while. I've got my new M4 Mini here with 64 gigs of RAM, and this takes about 5 minutes. I'm going to pause this here so we don't burn that much time. Okay, we're back. About 5 minutes has passed. We inserted 56,000 lines in about 5.2 minutes, and then 174 episodes in a sub-second. And one thing I wanted to point out is that the model, this sentence transformer from Hugging Face that we're using is this, is the mini LM, the all mini LM, and it was created using cosine similarity, so that's exactly what we used here. If the model that you're using to build these vectors is based on another type of metric, then you should probably use it, or try experiment with different things. Who knows? But there's some good resources out there for which one to decide upon using based on various characteristics of the data and the kind of searches that you want to perform. But anyway, we're here, we're through this search now, and it's time to run some queries in dgraph, finally, right? Here we have a simple client we're going to grab. This is the one of the most popular GraphQL clients that are out there, and for Python. And basically, we just grab a new one. We're hitting the endpoint, which is running again. dgraph is running inside this container. The line of just feelings of intense dread just came to mind today. What we do is we actually create the embedding using the same model that we passed in to insert our records, and so that line embedding kind of goes into a variable. Line embedding, see the query. It's query similar line embedding. And this again is one of those generated API endpoints that dgraph gives you when you have the embedding directive in a vector or an array, if you will. And yeah, so there we go. This basically you pass the predicate in the type that you want this vector to be performed against, the search to be performed against. And this top K is like the nearest neighbors from the algorithm. Let's give me the top 3 by vector distance. And we can execute that finally. And then what comes back is with feelings of intense dread. Similarity search gives us classic episode of the opera where Joe Davola says, "Good, fear is our most primal emotion." Elaine says in the contest, the classic episode, yeah, I'm really psyched. Okay, so, and then the watch, this one is if you ever feel I need to talk to someone. So these are the closest lines that I could find, based on that embedding. You might be saying to yourself at this point, like, all right, so you do the same thing, in Weaviate or in Pinecone, right, or whatever. Well, the difference, of course, is in dgraph, the embeddings are directly stored with the type itself, which, of course, you typically have links or edges to other types. And you can kind of see from this query, we've done something, kind of wacky here with this. We're querying the line by this embedding, but then we're going inside the episode, and then we're getting the lines from the episode. And then inside that episode, we're looking, then we link to the character, and then we're getting the first 5 lines that every character ever uttered in the series. And what that does is then obviously it gives you a lot more power when you're conducting searches like this. So here's like the whole that whole tree that I just extracted from the graph, just starting at the vector embedding itself, which I think is kind of a good selling point for why these are being brought into dgraph this way. So I think that's kind of powerful. And then obviously at this point, if you're doing retrieval, then your agent can sort of like start gleaning what these, like, as it goes down further and further into these different edges that each the nodes contain. They could then make decisions based on how you've decided to train them or instruct them. So that's sort of like the concept. Here's a query that is doing the same thing but with episodes. Joys of the holidays, and we find some episodes that the summaries seem to match holidays or something. And then finally, I wanted to show the query similar episodes by episode identifier. So that's the other type. So there's two types of similarity searches that dgraph emits. One is finding one by, you pass a vector that they find the ones that are close. The other is, find similar ones to this type that I just sent you. And this is what this query is doing here. So it's saying, I've got this episode, season 3, episode 12, and find me the most similar episodes to that. Now it does return the one that I identified, and I guess that makes sense. So if you wanted 3, maybe you would have to include the four nearest neighbors, and that way you could just discard the first one, because of course the first one should be a direct match, of course. So yeah, there you have it. That's real quick look at vector based similarity search in dgraph that was introduced in v24. There are some caveats. I want to just go real quick. One is the data from this Docker container that you're running is not persisted anywhere, so I didn't map the volumes or anything. Complicates things. So just be aware that when you kill this container, you're gonna lose the data. It wouldn't be hard to map data to a volume of your own if you wanted to do that. And then there's another thing, that there's no auto updating of these vectors, meaning like if you just update a line, for instance, in an episode, that vector won't get auto generated. You have to kind of marry the two together. You have to constantly, let's say if you update something that's being backed by a vector, you have to update that yourself. I think dgraph's parent hypermode is working on they're doing this, so they're making it more seamless. But for using dgraph raw, you have to maintain those yourself. And from the testing that I've done, there seems to be some issues with cascading queries when using these generated queries similar by embedding operations, or these endpoints that it creates. So just to give you an example, for instance, here's a classic sort of cascading filter in dgraph where I want to look for the word bagel, but only in season 9, right? And there they are, the four references in season 9 about bagels. If I try to do something similar with these top-level query similar API endpoints, there seems to be some issues. So if I was to issue this, it's basically the same thing. I'm cascading from this root query, and then I'm filtering below just out of season 9. And if I run that, then what happens is we're obviously getting results back that the filter is not restricting. So I also tried this in DQL. For those of you who know DQL, seems to be some issues there as well. So just that's caveat. Just you might not be able to do this cascading filtering at the moment until a dgraph fixes that. But other than that, it seems to be going pretty well. All right, that's it. I'll pause it here. Thanks again for watching. I'm Matthew McNeely. I'm an independent consultant, and if you have any need for consulting, please feel free to reach out. I'm available for dgraph and for other graph technologies and other things as well. I've got background in Python and Go and a lot of other things. So yeah, thanks for watching. And if you have any questions or comments, please leave them below. And like I said, I'll link any links today or commands that I've used here. I'll be sure to put them in the first comment so that you can follow along. All right, thanks a lot, everybody.